F-102A pilot emergency escape system was tested at Edwards Air Force Base test track using a 6-foot, 200-pound anthropomorphic dummy. A high-speed rocket sled simulating the F-102A airplane forward of Airplane Station 217.0 was the vehicle for the tests. The escape system was triggered by a metal arm attached to one rail of the track and an initiator installed on the outside of the cockpit. By this method, the emergency escape system was discharged at a predetermined point on the track. The complete pilot escape system was tested, including canopy jettison, seat and dummy ejection, automatic separation of the seat and dummy, and deployment of the dummy's parachute. The rocket sled runs over a standard gauge railroad track. The speed of the vehicle is determined by the number of rocket motors used to propel it. Solid fuel rockets were used. The initial test run was used to establish the operating efficiency of timing devices, camera equipment, the rocket sled, and instrumentation control. The rocket sled can cover the 10,000-foot distance of the experimental track in 10 seconds or less, depending upon the number of rocket motors used. 8 test runs were made. Speeds ranged from Mach 0.27 to Mach 0.99. Ejection of the dummy from the rocket sled was attempted only after initial tests had established that the operational equipment was functioning properly. Canopy jettison working smoothly. Because of the short time duration of the runs, the usual 2-second time lag between catapulting of the pilot and the automatic separation of the pilot from the ejection seat was shortened to 1 second for the tests. Here we see the operation in slow motion. In subsequent tests of the equipment, the angle of the cab was varied. A 10-degree angle was used to simulate slow-speed attack characteristics of an F-102A. A 2-degree angle was used to simulate high-speed flight. Vertical stabilizer clearance was determined from motion picture coverage provided by metric range cameras. This is another phase of the F-102 test program, a test program designed to accurately determine the reliability and performance standards of F-102 components. The F-102B mock-up board convened at Convair's San Diego plant in December 1955. Similar to the F-102A, the F-102B represents the latest design refinements of its class. A redesign of the missile bay section features 1 compartment instead of 3, and 4 doors instead of 6. The engine presently selected for the F-102B is the J-75. Ground steering is again controlled by the rudder pedals. Vertical tail area has been increased to 105 feet. Speed brake area is approximately doubled. Engine removal is through the rear. The canopy, cockpit, and canted bulkhead are located 20 inches further forward. The complete mock-up included the Hughes MA-1 system and cockpit arrangement and showed a side-mounted control stick. To demonstrate side console accessibility and simulated seat ejection, an Air Force pilot was outfitted with a full complement of personnel gear. This demonstration also presented the equipment and procedure for ground jacking the airplane. The cross-sectional area of the B airplane fuselage has been reduced. Wing root fillets now flow smoothly into the tail section. Wing leading edge camber is carried to the tip. The first prototype of the F-102B is scheduled to make its first flight in December 1956. This is the TF-102A Combat Proficiency Trainer. It is the trainer version of the supersonic F-102A all-weather interceptor. With the exception of the pilot compartment, the TF-102A is very similar to the F-102A, carrying the same armament and equipped with identical power plants. The nose sections of the TF-102As are manufactured by the Fort Worth, Texas division of Convair. This plant is the same one that produced the Air Force jet-augmented B-36 intercontinental bombers, now active in B-58 and certain atomic programs. A completed nose section is immediately transported to Convair's San Diego facility, where the wings and fuselage sections have been simultaneously produced. The two divisions, although located at separate facilities, operate as if located in the same plant area. At San Diego, the two sections, products of carefully planned coordination, are moved to the assembly line for mating. The task is more easily accomplished through the new application of optical alignment. From San Diego, the assembled TF-102A is moved to Edwards Air Force Base near Palmdale, California. There, the TF is checked out by ground crews and engineers. Instrumentation, systems, power plant, all preparatory to the trainer's initial flight. In the TF-102A, the instructor sits on the right side of the cockpit, next to and not behind the student. This arrangement is practical in many ways, providing for better instructor visibility, closer student supervision, and resulting in a higher safety factor. Ground maintenance and pre-flight procedures are the same for the TF as they are for the F-102As. Both types take to the air with fast and steep climb-out. Although designed as a trainer, the TF-102A is capable of operating as a fully tactical interceptor aircraft, a double use for a dual airplane. In the early phases of flight testing, varying amounts of buffeting were encountered below the transonic region. This was overcome in two ways, by the use of vortex generators and redesign of the canopy. In the air, the similarity between the TF-102A and the F-102A is quite noticeable. Both airplanes have the same wings, the same aft section, the same tail. The design of the TF-102A Combat Proficiency Trainer is a step forward in the Air Force Interceptor program. The TF-102A, first trainer version of any of the Century series of combat airplanes, supplement to the Air Force pilot training program for the F-102A all-weather interceptor. Holloman Air Force Base. Something has been added to the F-102's armament load. Originally designed to carry only rockets and Falcon missiles, the kill power of the interceptors has been increased by the optional loading of another missile, the air-to-air Type MB-1. However, before final decisions could be made, extensive ground firing tests were required. First, it was necessary to determine the pressures and temperatures of the missile blasts and their effect on the airplane fuselage structure, and whether titanium or stainless steel would be required in the blast area of the fuselage. Also, if any fuselage structures would require reinforcing due to the pressures, and if the main landing gear doors and various access doors would be blown off by the blast. To accomplish this task, an F-102 test fuselage was constructed with the belly side up. The missile was fired and launched from a position simulating the airplane-missile position relationship of an actual aerial firing. The test firings of the missile were conducted jointly by Convair and Air Force personnel. The blockhouse procedures and actual firings were the direct responsibility of the Air Force.
4, 3, 2, 1, 0.
This firing in slow motion was taken at 1,000 frames per second. The Mach diamonds can be easily studied by this camera speed. After each firing, the test fuselage was carefully inspected for the blast and pressure effect in the critical areas. Concurrent with the test firing program, evaluation flights were made with the missile in the extended firing position. These scenes show the missile in a fixed position, but normally the missile would be carried inside the missile bay until such time as the pilot of the aircraft chooses to release and fire it. A feature of the F-102 airplane is that all armament is carried within the contour of the fuselage. Following the ground firing test, the F-102 armament will be fired from an F-102 airplane confined by this tethering rig. These tests will simulate firing under actual conditions. For the first time, the camera crew was able to photograph the complete armament load of the missile and rocket together with the airplane. It represents a terrific amount of kill power. Production flight test for the F-102A is located at the Convair Voltaine area, Palmdale Airport, near the community of Palmdale, California. Here, final production flight testing and Air Force acceptance of the F-102A is accomplished. In order to meet the overflow, interim hangars connected by taxiways to the present location have been established approximately 1/2 mile away. An airstrip, no longer in use, was utilized for this facility. Quonset huts serve as storage buildings and operational offices. The hangars seen here are 148 by 160 feet and are built over the runway. Approximate cost, $200,000. Electronics operations are at present conducted at the Lockheed facility nearby. Approximately 4 miles north of the present base, construction was begun on a permanent installation. The first of 8 buildings is shown here in the initial stages of construction. It is expected that electronics operations will move to this 150 by 675-foot building by the latter part of July 1956. Total plant area of the approved new site will be approximately 420,000 square feet. The approximate cost of the presently approved development will be $9.5 million. At Convair's San Diego plant, construction was begun on the new F-102 field operations area and flyaway stations. This is the final production stage for the F-102 before its removal to Edwards Air Force Base and Palmdale for flight and production tests. First models of this airplane were trucked to the Mojave Desert Base. Later production models were flown out. Expansion of the F-102 program necessitates the addition of these facilities. Built at an approximate cost of $342,000, the additional area will include a concrete apron, operational offices, a small hangar, and emplacements in which pre-flight engine testing will be done. When completed, the new area will furnish adequate space and facilities for necessary field operations in preparing the F-102 for flyaway to the test center. Cold weather testing of the F-102A was undertaken at Ladd Air Force Base, Alaska. Testing included a 12-hour cold soak of the airplane, and after a night out, the F-102A was cleared for test operations. The Delta Wing all-weather interceptor was subjected to cold weather conditions which it might feasibly encounter in tactical operation, initiated in order to determine the effect of sub-zero weather upon ground operation and flight characteristics of the F-102A. Captain Tracy B. Mathewson of WADC piloted the plane during these tests. 10 test flights were made under varying conditions in 30 degrees below zero mean average temperatures. Runways were cleared by snow plows prior to the F-102 takeoff. The tests revealed that extremely cold temperatures have no significant effect upon the airplane's performance. Takeoff characteristics, climb out, and response to controls proved to be satisfactory. Engine thrust was increased due to the greater density of the cold air. Takeoff run was shorter, rate of climb was steeper. Provisions were made during the program for testing the F-102A armament. 2-inch rockets were used. 2 armament tests were conducted, both at an altitude of 30,000 feet. During one of the runs, the F-102A was traveling at Mach 0.86, and 12 of the 2-inch rockets were fired. For the other test, a speed of Mach 1.15 was attained, and 17 of the 2-inch rockets fired. Participating in the cold weather testing of the F-102A were WADC personnel, engineering and photographic representatives from Convair, and personnel of Ladd Air Force Base. Results of these tests, when thoroughly analyzed, will furnish valuable data for the complete United States Air Force F-102 interceptor program.